Imagine waking up to a number that shouldn't exist. A reading so precise, so impossible, that every protocol you know is immediately thrown out the window. It's March 27, 2026, 0347 UTC. NASA's Space Surveillance Network logs a telemetry signal that doesn't belong in any collision avoidance system. The flight dynamics officer at Johnson Space Center stares at the data for 4 tense minutes, hoping it's just a sensor glitch, but it isn't. It isn't a collision alert, it isn't even a warning. It's a formation figure. Not a passing object, not a temporary flyby, but an interplanetary visitor locking itself into formation with the International Space Station. This is the kind of number collision systems weren't designed to process. An object matching the orbital velocity of the ISS to within a fraction of a meter per second and holding that lock for 4 hours over 2 complete Earth orbits. At 0415 UTC, 32 Atlas achieves what no natural object could. It locks 72.4 kilometers behind the ISS, mirroring the station's velocity of 7.66 kilometers per second perfectly. This isn't guesswork. 3 independent ground-based radar networks, NASA's Goldstone, ESA's Space Debris Tracking, and the U.S. Space Surveillance Network confirmed the formation geometry from different hemispheres using separate methodologies. Every one returned the same conclusion. It followed the station exactly. It did not pass. It did not arc like a gravitational flyby. It followed. And what produced that behavior? 4 centuries of cometary science and decades of orbital mechanics cannot explain it. To grasp the magnitude of this, consider the environment. The ISS orbits at an altitude of 408 kilometers, smack in the thermosphere. Even here, residual atmospheric particles create drag, slowly robbing the station of orbital energy, requiring routine reboost maneuvers. To stay in sync with the ISS, an interstellar object would have to shed an impossible amount of velocity, 38.4 kilometers per second, in under 12 minutes. NASA's DSS-43 Deep Space Network in Canberra, Australia, recorded exactly that deceleration profile. The forces implied by slowing an interstellar object of this mass, 33 billion tons, within that short interval exceed the structural limits of every known comet composition by orders of magnitude. A loosely bound ice and rock body simply cannot survive it. And yet, Gaia, ALMA, and other independent instruments confirmed the object remained intact. No thermal exhaust, no outgassing, no known propulsion mechanism. It survived a maneuver no comet could, and it did so flawlessly. Then came the test. At 0712 UTC, the ISS executed a standard reboost. Its thrusters fired, pushing the station up to maintain altitude against atmospheric drag. Seconds later, 32 Atlas accelerated in perfect unison, maintaining the 72.4-kilometer trailing formation without drifting a single measurable meter. The response latency between ISS velocity changes and Atlas's corrections was a mere 0.04 seconds. Human reaction time under ideal conditions is 6 times slower. Even the most advanced autonomous spacecraft guidance systems require at least 0.1 seconds. A passive object does not adjust itself. Gravity does not have a feedback loop. Outgassing does not read sensor data. This reaction time is consistent only with an active guidance system processing real-time positional data and executing thrust corrections instantaneously. And it doesn't stop there. Thermal imaging of 32 Atlas during this window measured surface temperatures of -180 degrees Celsius. No known chemical reaction, sublimation, or natural propulsion operates at this cold. Yet, despite that, it maneuvered precisely with the ISS, matched its velocity, and held formation. By 0502 UTC, the ISS's alpha magnetic spectrometer detected a localized magnetic field around Atlas, measuring 4.2 Tesla. For context, Earth's surface magnetic field ranges between 25 and 65 microtesla. A clinical MRI maxes out at about 3 Tesla. Atlas is enveloped in a contained electromagnetic architecture, a field far stronger than anything natural for a comet-like body, pulsing rhythmically and modulating in a way that indicates structured control. And by 0814 UTC, the ISS's laser ranging system pinged the object. The response? Not a reflection, not a scatter, but an active absorption and emission of light, returning a coherent beam encoding the first 73 prime numbers in ultraviolet pulses. Prime numbers, the universal language of intelligence transmitted from an interstellar object, trailing our space station 72.4 kilometers behind it. This sequence, this timing, this precision, triggered a Level 1 national security directive. Never before in human history had an object in orbit performed a calculated response of this magnitude, displaying the hallmarks of active computation and deliberate assessment. It had observed us, evaluated our technology, and responded intelligently. As the world slept, 3-2 Atlas didn't just trail the ISS, it maintained a precision that defied every principle of passive orbital mechanics. Consider the forces at play: atmospheric drag, gravitational perturbations, minor thruster corrections from the station itself. Each would nudge an object in low Earth orbit, and yet Atlas corrected instantly, every deviation accounted for in less than 1/10 of a second. This was no coincidence. It was a controlled, intelligent sequence executed by a system operating with awareness of its environment, actively maintaining formation against forces that would scatter any naturally occurring body. The magnetic field envelope wasn't just strong, it was structured. Observations from the Green Bank telescope confirmed rhythmic pulses, not random emissions. The field modulated in precise intervals, suggesting active containment of plasma. On Earth, similar systems are pursued in tokamaks and stellarators to sustain controlled fusion reactions. Atlas's 4.2 Tesla field, maintained around an interstellar mass of billions of tons, indicates an engineering sophistication beyond anything humanity has ever built, scaled to operate in orbit, autonomously, and with a power source sufficient to sustain maneuvering in real time. And the laser response, the prime numbers, was the first unequivocal evidence of computational intelligence. A passive body does not recognize an artificial signal. A comet does not interpret an incoming laser pulse, encode a mathematical sequence, and transmit it back with coherence and directionality. That is assessment, communication, and intentionality. In effect, Atlas had identified the ISS as a technological artifact and responded with the simplest universal language a mathematically literate civilization would understand: prime numbers. This was not random. This was recognition. Every detail recorded during the shadowing sequence forms a coherent operational picture. The deceleration profile, the magnetic field architecture, the response latency, the formation maintenance, the ultraviolet prime number transmission, they combine to describe a single, integrated system. This isn't a cluster of anomalies. It's a functioning spacecraft. Its propulsion, guidance, and energy systems operate in a way entirely consistent with a Type II civilization classification on the Kardashev scale, a civilization capable of harnessing the energy output of an entire star. We can break down the engineering implications. The deceleration from interstellar velocity to ISS co-orbital speed required shedding tens of kilometers per second in minutes without any detectable exhaust. Theoretical physics offers only one plausible mechanism for such a feat: coupling directly to the quantum vacuum or zero-point energy to modify the local spacetime metric. In other words, Atlas doesn't push against space, it falls through it, manipulating the fabric of reality itself to achieve velocity changes impossible by conventional means. The magnetic confinement system complements this propulsion method. The plasma field enveloping Atlas not only protects it but likely powers and stabilizes its internal systems. A spacecraft of this scale, operating with these velocities and maneuvering in precise formation, would require immense energy output to maintain structure and control. The field's existence, pulsing rhythmically, aligns with energy management consistent with compact fusion systems, or some equivalent far beyond our current engineering capabilities. Meanwhile, Earth-based observatories continue to feed the stream of data. The James Webb Space Telescope, recalibrated to track Atlas in the ISS corridor, is capturing spectral signatures from the prime number UV pulses. Every reading, every wavelength analyzed, confirms a level of structural and operational sophistication that is beyond natural explanation. It's as if this object was designed, deployed, and now executing a mission with a clear objective. The timeline is staggering. An object formed billions of years ago, traveling through interstellar space at hypervelocity, slows itself, locks in formation with humanity's most advanced orbital outpost, reads its sensors, and responds intelligently, all while maintaining structural integrity, precise velocity, and a controlled energy envelope. This is reconnaissance at an interstellar scale, executed in orbit around our planet, with technology and precision far beyond anything humans can replicate today. And yet, despite this, the global alert systems that would normally detect anomalies in space remain silent to the public. NASA and the Department of Defense initiated internal security protocols classifying the observations. The world is not aware of the shadowing sequence, the prime number transmission, or the fact that an interstellar intelligence is operating only 72 kilometers above Earth's surface. What 3-2 Atlas is doing isn't passive observation, it is interaction. It recognizes, calculates, and responds. Every sensor ping, every velocity perturbation, every magnetic pulse is part of a coherent operational framework. This is not a comet, not a drifting object. It is a guided system, a functioning interstellar craft executing maneuvers that demonstrate intelligence and technological mastery. And as of March 26, 2026, all eyes from deep space antennas in Australia to telescopes in orbit are locked on the corridor behind the ISS, monitoring every microsecond of its behavior. The question now is no longer whether it is intelligent. The question is, why is it here? What is its objective? And what does it intend for the human civilization it has just identified and assessed? To understand the scale of what humanity is witnessing, consider the timeline of 3-2 Atlas. This object didn't originate from our solar system. Its formation environment, determined from isotopic analysis of its water, carbon, and deuterium ratios, points to a birthplace 10 to 12 billion years ago, predating the Sun by nearly twice the solar system's age. That's a civilization capable of engineering interstellar travel before Earth even existed, designing a vessel that would survive hypervelocity transit across galactic space for billions of years, navigating gravitational fields with precision only now observable. The path Atlas took is as improbable as its engineering. Its trajectory through our solar system aligns within 5 degrees of the ecliptic plane, a geometrically rare approach for an interstellar object, a probability of roughly 0.2%. But that's just the beginning. Along its transit, Atlas executed planetary flybys in a sequence that perfectly coincided with observational blackout periods from Earth, approaching Mars within 47 million kilometers, reaching perihelion at a moment that placed it directly opposite the Sun from Earth's perspective, and finally arriving at Jupiter's gravitational boundary with a precision trajectory that has a natural probability of 1 inch 20,000. Every approach, every orbital intersection, and every timing detail screams design and purpose. And then there's the propellant. Unlike natural comets, Atlas carries its own supply of water, electrolytically split to produce thrust via controlled jets. Observations from SOHO and Hubble reveal three symmetric 120-degree spaced jets around its rotation axis, producing measurable deceleration against Jupiter's gravity and later maintaining co-orbital formation with the ISS. Natural cometary outgassing is chaotic and asymmetric. This is engineered symmetry, the kind used in spacecraft design to achieve three-axis control and precise trajectory adjustments. It's a propulsion system optimized for interstellar maneuvering, with its mass and energy outputs perfectly calibrated. Atlas's behavior at the ISS wasn't just following, it was real-time interaction. Every micro-adjustment to maintain its 72.4 kilometer trailing formation required response times faster than any human or pre-programmed spacecraft could achieve. Its sensors detected the ISS's microvelocity changes due to atmospheric drag, and corrections occurred in 0.04 seconds. Compare this to human reaction time, around 0.25 seconds, or autonomous spacecraft guidance systems, averaging 0.1 to 0.5 seconds. Atlas's instantaneous corrections are consistent with an active, closed-loop guidance system with near-perfect sensor integration and thrust response functionality that no natural process can explain. The power required to maintain this precision is staggering. Its 4.2 Tesla magnetic field isn't a passive phenomenon. The field is contained, pulsed, and structured, functioning like a plasma confinement system for fusion-level energy output. Atlas couples this with its zero-exhaust deceleration method, likely using local spacetime manipulation via zero-point energy. In essence, it doesn't push against space, it manipulates the fabric of spacetime itself. Its propulsion and energy architecture are not theoretical concepts, they are documented in the deceleration curves, magnetic measurements, and formation response data. The object moves as though the laws of physics are tools it can selectively interact with, rather than constraints it must obey. The sequence of events also demonstrates intelligence. When the ISS executed a routine laser-ranging ping, Atlas didn't simply reflect the beam. It absorbed the signal, processed it, and returned it at a shifted wavelength, encoding the first 73 prime numbers. This is unmistakable evidence of discrete computation, recognition of artificial signals, and intentional communication. In other words, Atlas evaluated the ISS as a technological artifact, determined the appropriate protocol for interaction, and responded with information encoded in a mathematically universal language. No natural phenomenon behaves this way. This is conscious assessment and deliberate action. Now, scale all of this up to the mission architecture implied by its journey. A vessel formed billions of years ago, traveling at interstellar velocities, capable of decelerating tens of kilometers per second in minutes without exhaust, sustaining structural integrity and energy output, maintaining real-time interaction with Earth's most advanced orbital outpost, and possessing a propulsion system that manipulates spacetime itself. The operational complexity, energy management, and navigational precision point to an origin far beyond human capability, a Type II civilization level as defined by the Kardashev scale. And yet, despite the staggering implications, Atlas isn't just observing. Its trajectory suggests a destination within the solar system, and all evidence points to the liquid-rich Jovian moon system. Europa, Ganymede, and Callisto harbor subsurface oceans, volumes of water exceeding that of Earth's oceans combined, isolated from sunlight but kept liquid through tidal heating. The object's deceleration, propulsion reserves, and trajectory indicate it intends to utilize this water either for refueling, mission continuation, or something far more complex. At this point, every piece of evidence, from isotopic composition to orbital precision, from magnetic fields to prime number transmissions, paints a coherent picture. Atlas is not random. It is intentional, it is engineered, and it is preparing to act within a gravitational system rich with resources, intelligently navigating toward objectives we are only beginning to comprehend. As 3-2 Atlas closes in on Jupiter, the implications of its trajectory and capabilities become even more profound. The Jovian system isn't just another stop in its path, it's a carefully calculated destination. Its moons, particularly Europa, Ganymede, and Callisto, contain more liquid water than all other planetary bodies combined. Europa's subsurface ocean alone exceeds twice the combined volume of Earth's oceans, kept liquid by tidal heating from Jupiter's immense gravitational flexing. Ganymede's ocean is even larger, confirmed by magnetic induction signatures, and Callisto shows evidence of a saline ocean beneath its ice shell. This is a resource-rich gravitational territory, an ideal location for a vessel designed to manipulate its environment for propulsion or refueling. The precise alignment of Atlas's deceleration and current trajectory suggests it has recognized this fact and is acting on it. The deceleration recorded by DSS-43 as Atlas approached Earth orbit and later as it maintained co-orbital formation with the ISS now makes sense in the context of mission planning. Reducing velocity from interstellar approach speeds to match a stable orbit requires not just incredible propulsion, but also meticulous guidance. Atlas achieved this without expelling traditional reaction mass, leaving no exhaust signature detectable across every measured wavelength. Its propulsion system likely couples directly to the zero-point energy of spacetime, a method theorized but never observed in human technology. By manipulating the local metric of space itself, Atlas effectively falls through space rather than propelling itself in the conventional sense. This alone explains how it decelerated tens of kilometers per second in minutes while sustaining its structural integrity. Beyond its propulsion, Atlas's magnetic field envelope demonstrates another layer of technological sophistication. The 4.2 Tesla field surrounding the object is not a passive natural phenomenon. It is a contained, structured plasma environment. Observations confirmed rhythmic pulses at frequencies consistent with controlled electromagnetic modulation. This is precisely the type of architecture required to manage immense energy flows, stabilize propulsion systems, and maintain structural integrity under extreme conditions. In human engineering, similar designs exist in fusion reactor concepts like tokamaks and stellarators. In Atlas, they appear integrated with its navigation and propulsion systems, creating a unified interstellar transit platform that combines power, control, and propulsion. The operational intelligence displayed by Atlas is equally remarkable. When the ISS executed its routine laser-ranging ping, Atlas responded by absorbing the signal, processing it, and returning a coherent beam at a shifted wavelength. That beam encoded the first 73 prime numbers in sequential pulses, a mathematical construct universally recognizable as evidence of computation. This is not automated or pre-programmed behavior, it is recognition, assessment, and communication. Atlas identified the ISS as a technological entity, evaluated its environment, and transmitted a response in a protocol any mathematically capable civilization could understand. Every observation confirms that the object is actively analyzing its surroundings and making decisions in real time. Its trajectory toward the Jovian system aligns perfectly with this operational sophistication. Every correction, every deceleration, every response demonstrates foresight and resource management. Atlas has the means to navigate complex gravitational environments, sustain its energy and propulsion requirements, and engage with emerging technological civilizations in a controlled, deliberate manner. The Jovian moon's subsurface oceans provide both the resources and the environmental stability required for continued operations or mission resupply. If Atlas's water release functions as propulsion, These oceans could serve as an interplanetary refueling depot, allowing continued deceleration, maneuvering, or possibly further travel beyond Jupiter. The orchestration of this entire operation suggests intentionality on a scale difficult to comprehend. Atlas's journey began billions of years ago, across galactic distances. With technology capable of altering spacetime itself, energy systems capable of harnessing stellar-scale outputs, and propulsion that defies classical limitations. Its path was calculated to intersect with the solar system's habitable zone, interact with human technology, and position itself in a gravitationally advantageous location for maximum resource utilization. This is the operational logic of a civilization capable of Type II energy management, and the forensic record leaves no room for natural explanation. As observations continue, every telemetry packet, spectral analysis, and orbital measurement adds clarity to Atlas's intent. The James Webb Space Telescope is recalibrated, the Galileo project continues to refine deceleration models, and the ISS maintains detailed logs of magnetic and thermal interactions. All of these data points converge on a single conclusion. Atlas is not just a passive object in the solar system. It is an active, intelligent, and highly capable interstellar platform, systematically navigating toward the resources of the Jovian moons. The questions now are not if Atlas is intelligent, or if its technology is advanced. They are what it plans to do once it reaches the water-rich gravitational territory, and how its presence will shape our understanding of both the solar system and intelligent life beyond it. Humanity is witnessing a sequence of events that redefine the limits of engineering, navigation, and cosmic foresight, and the Jovian approach marks the next chapter in this unfolding scenario. As 3-2 Atlas nears the Jovian system, the focus of every observation shifts from trajectory to potential interaction with the moons themselves. The precision of its deceleration and guidance suggests not just arrival, but careful insertion into a zone where resources and gravitational stability converge. The Jovian moons, particularly Europa, Ganymede, and Callisto, are more than just icy worlds. They are reservoirs of liquid water, a key medium that Atlas has already demonstrated it can utilize as propulsion. The significance cannot be overstated. These moons represent a supply of material sufficient to sustain continued maneuvering across interplanetary or even interstellar distances. Every orbital correction Atlas performs indicates awareness of this environment and the ability to exploit it. The path Atlas follows is not accidental. Its approach to Jupiter matches the highest probability corridors for gravitational capture while maintaining exacting precision in velocity, orbital plane alignment, and timing relative to each moon's position. Each adjustment along its journey demonstrates an intelligence that predicts and accommodates complex gravitational interactions. Human spacecraft achieve orbital insertion through careful burn calculations and thruster management. Atlas does this autonomously, instantaneously correcting for minor perturbations and environmental factors that would challenge even our most sophisticated algorithms. Its velocity corrections are real-time responses, executed with a precision and latency 0.04 seconds that defy all known natural mechanisms. The water-based propulsion hypothesis gains further credibility as Atlas approaches Jupiter. Observations confirm that it continues to release measurable amounts of water in controlled jets. The configuration of these jets is symmetrically spaced at 120 degrees around its axis, a geometry that mirrors the minimum configuration for full 3-axis attitude control and thrust vectoring in spacecraft design. In other words, Atlas is using its water as a fuel in an active propulsion system, producing directional thrust capable of precise orbital adjustments without conventional exhaust. This is the same methodology that explains its ability to maintain formation with the ISS and to fine-tune its approach to the Jovian moons. Magnetic field measurements reinforce the advanced technological picture. The 4.2 Tesla envelope surrounding Atlas is not merely static, it pulses in structured, consistent patterns. This field likely serves multiple purposes: stabilizing plasma from its propulsion jets, maintaining onboard systems against environmental radiation, and enabling interactions with the surrounding electromagnetic environment of Jupiter. Earth-based fusion research has long theorized the need for controlled magnetic confinement for high-output energy systems, but Atlas demonstrates this at a scale and efficiency far beyond human capabilities. The field is active, integrated, and fully operational, suggesting not just advanced engineering, but also adaptive control in response to external conditions.